Hello everyone and welcome to this extremely important video for AP Calculus. This is going over a typical FRQ, and the thing about this particular type of FRQ is that it has been on basically every single AP Calculus exam ever in some form. Okay, not this exact question, but these calculations where you have a function that is an integral of another function, and then they ask you to calculate, g at a number, g prime at a number, and g double prime at a number. This is typical AP stuff, and you're going to see this on your exam. I guarantee it. Okay. There's actually 3 more parts to this question. I'm not sure how far we're going to get in this video. We're at least going to do this. We might do the other 3 parts in this video, but we might split it up into some other videos. I haven't decided. But let's go ahead and do this. So what we're told is that from -2 to 0, which is here, that we have a polynomial. And we also have a polynomial from 2 to 4. So here's x equal 2. Here's x equal 4. So this little region here, I didn't draw it the best, but you get the idea. These are polynomials, and everywhere else, so from 0 to 2, we have a line segment. This is a straight line. And then from 4 to 6, we have a straight line. All right, good. Now, g of x is defined as the integral from 0 to x of f of t dt, and of course, this is f of t. Okay. So this is the graph of f right here. Okay? Awesome. Okay. So, like I said, this is super typical. This is one of the most important videos I've ever made with regard to AP Calculus. So let's make sure we're paying attention. Let's find g of 2. So all we're going to do is replace x with 2. We get integral 0 to 2 of f of t dt. Okay? And so let's think about what that is. Okay, well, here's the graph of f. We need the integral of f from 0 to 2. Okay, well, here's 0, here's 2. So the thing that this problem is asking for right now is this area here. And hopefully we can see, by doing this drawing here, hopefully we can see that we can actually calculate this very easily by using triangles. Okay, and so let's do this. So it was a right triangle. Let's do 1/2, and then the base of that triangle was 2, and the height of that triangle was 4. So 1/2 times 2 times 4, and then the 2's and the 2's go away, and we just get 4. All right, g of 2, not bad. There we go. G prime of 2. Okay. Well, so that's the derivative, right? So we have to do d by dx of the integral from 0 to x of f of t dt, right? And this looks extremely complicated, but if you just remember the fundamental theorem of calculus part 2, which is already done in a previous video, check it out if you're not sure what this is just going to give us f of x. Okay? Basically, plug in the x, and then the derivative of x is 0. And then plug in 0, get f of 0, but the derivative of 0 is 0 as well. So we just get f of x. Okay? And now we're going to swap x with 2. Okay? So in other words, g prime at 2 is the same thing as f at 2, okay? And what is f at 2? F at 2 is exactly 4, okay? So g prime at 2 is going to be 4. Awesome, okay? Now, what do we have? We have g prime is f. If I take another derivative, g double prime is f prime. Okay, so in other words, the second derivative of g is going to be the first derivative of f. And what is first derivative? First derivative, ladies and gentlemen, is slope. Okay, so in other words, to find the second derivative at 2, we need the first derivative at 2, or in other words, we need the slope at 2. All right, now let's remember the following, right? Let's remember that the derivative at 2 is literally going to be the limit as h approaches 0, f at x plus h minus f of x divided by h, right? Now this is a limit. This limit has a left and right hand limit associated with it. So let's look up here, okay? The left-hand slope here, because we're talking about, here's 2. To the left of 2, the slope is actually exactly 2. Okay. Now, coming off of this point here, this polynomial appears to have slope 0. Okay. Look, it looks like it's flat here, and I believe it actually is. But the point is this. The point is the slope instantly changes from 2 to what appears to be 0. So there's a jump in the slope. There's a jump discontinuity in the slope, okay? Which means the derivative doesn't exist, okay? So we have a corner. We have a corner at x equal 2. So f prime at 2 is not going to exist. Okay. So there we go. So there's g at 2, g prime at 2, g double prime at 2. Okay. Now, for the next part of this problem, we have this situation. It says for the function g in part A, find the x-coordinate of each point of inflection. So we want x-coordinate of inflection point. Of the graph of g from -2 to 6. Okay, and there's non-equality here. It means we don't have to consider endpoints. So endpoints not needed. So that's good. Okay, awesome. So x-coordinate of inflection point of g from -2 to 6. Okay, well, once again, we know that g prime is equal to f of x. Okay, now let's remember inflection points, right? So a little unit 5 review here. Inflection point happens when the second derivative changes sign, right? So we want the second derivative of g, which of course is going to be the first derivative of f. So we want to know where does the slope of f change from positive to negative, or the opposite, right? Any sign change, or negative to positive. That's what we're trying to figure out here. Okay, that's going to give us our inflection points. Okay, so let's go back up to our graph. And let's take a look here. So positive slope, 0 slope, but then we're positive again. So no sign change. So positive, but then we switch to negative here. Yeah. So right here, this is going to be what we're talking about right here. This is where the slope changes from positive to negative. Okay, so at x equal 2, f prime changes sign, specifically positive to negative. Okay, so therefore g double prime, or I'm sorry, x equal 2 is an inflection point. That's what I meant to say there. Okay, what else we got? Let me take a look here. All right, so for the next part here, we have h as a function, and we want to do extrema for this function. So specifically, what it has for the next part, for part C, is this. It says we have a function h of x, which is the integral from -2 to x f of t dt. Find the value of x for which h has a maximum. And then it says justify. Okay. So a few things to consider here. It doesn't say anything. There's no restrictions on anything. So anytime we're doing a max or a min, if there's no restrictions or anything, we have to consider end points. Okay. So in other words, so here's an end point at -2, and here's an end point at +6. Okay. So we have to consider end points. So let's do that. Okay, so h at, let me see here, h at -2, which is going to be the integral from -2 to -2. That's going to be easy. F of t dt. Everyone should know how to do this integral. Everybody in the world should know that's going to be 0. Okay, and then the other endpoint is +6, right? So we're going to go integral -2 to +6, f of t dt. Okay. Interesting. All right, let's think about this for a minute, because we don't have everything we need, so that means we got to think about something. Let's think about where the integral has to be a maximum. Okay, so if I integrate from -2 to 6, yeah, we have to be clever here. Because it doesn't give us everything to solve by hand. But if you stay with me here, if we go from because to go from -2 to 6, we have to go through 0 first, right? So this area, this accumulation is below the x-axis. This is negative. Okay, this purple accumulation here. Okay, and similarly, we're going to have a negative accumulation here as well. Because again, we have to go from -2 to 6. Okay, the positive accumulation is going to happen here. Okay, and yeah, so this green accumulation is positive. Okay. Okay, so basically, 6 will not be a maximum because this is a negative accumulation. And this is going to subtract from the green positive accumulation that we have here. Okay, so yeah. So in other words, this equals the negative purple plus the green minus the small purple triangle. Okay, and so because this is present, we're not going to have a max. Okay, so in other words, x equals 6 is not a max. Yeah, we're gonna come back to this in just a second. Let's just stick with this for now. Okay. So now the interior, right? Now the interior. We are looking for, because yeah, here's h. We want to maximize h. Let's remember, how do we find extrema of a function, right? Right. If I want a maximum, what does my derivative have to be? My derivative has to be 0. And my derivative has to go from positive to negative, right? Both of those things have to be true. 0 slope and goes from positive to negative. So let's calculate the slope of h. And it's also going to be, no surprise, just f of x. Okay? And so if I set this equal to 0, or undefined, okay, from -2 to 6, from -2 to 6, f is defined everywhere, so we actually don't have to consider this. So we only have to consider the interior where f is going to be 0, and where, the slope of h, which is f, goes from positive to negative. Okay. So, well, here f goes from negative to positive. Here f goes from positive to negative. Okay, so boom, boom, boom. There we go. X equal 5. So at x equal 5, h prime, which is f, changes sign from positive to negative. Therefore, x equal 5 is a max location. All right. So that's the location of the max, and the problem is asking for the actual value itself. Okay, so how do we find the y value of this thing? Well, we just got to plug in 5, but we got to plug in 5 to h, right? So let's do that. H. Yeah, so h at 5 is going to be the integral from -2 to 5 of ft dt. Okay, -2 to 5. Oh, I'm sorry. I just reread the problem, and we actually don't have to find the y value, which is good because we can't with the information given. So x value, we're done. Okay, there is one more part to this problem. We've done parts 1, 2, and 3. There's one more part, and that is right here. So part D. Part D. So it's still the same function h, which is integral negative 2 to x f of t dt. Okay. It tells us h at 0. It tells us straight away in the problem that h at 0 is negative 2, and in the problem it tells us that h at 6 is 26 over 3. And the problem wants us to find the integral from 2 to 4 of f of t dt. Okay? All right, integral from 2 to 4. Interesting. Where's 2 to 4? Let's 2 to 4. Okay. Okay, we can do this. We can do this. We can do this. Integral from 2 to 4. Okay. And we know something about 0, and we know something about 6. So let's do this. Okay. It tells us these two things. So let's do this. Let's do the integral from 0 to 6 of f of t dt. There we go. Give me 1 second here. Okay, let's just see how this goes. Okay, so I'm going to split this up. I'm going to split this up in the following way. Integral 0 to 2 f of t dt plus integral 2 to 4 f of t dt plus integral 4 to 6 f of t dt. Okay. All right, now in the problem it tells us some things, right? So h at 0, which is the integral from negative 2 to 0, oh, okay. So we get so we need to go from negative 2 to 6. Okay. All right. So So let's do, instead of 0 down, let's do negative 2. So then this will be, sorry, we'll just get rid of this. This will be integral negative 2 to 0 plus integral 0 to 2 plus integral 2 to 4 plus integral 4 to 6. Okay, now let me think here. You know what? I think my brain just stopped working. I'm gonna have to come back to this problem, part D, another time, or maybe we can work it together in class or something like that. Right now, my brain just shut down. I'm gonna have to call this video.